For f of x equals 9 over x minus 8 and g of x equals 8 over x, find the following composite functions and state the domain of each. We want to find f composed with g composed with f composed with f, and g composed with g. So let's start by finding the composite functions. For part A, we want to find f composed with g of x. Now this operation of composition is an operation that means to substitute one function inside of the other function. So if we know that, we can rewrite this notation to help us have a better understanding of what we're doing. The function that is on the outside is the one that's written first, and the one that's after the composition is the one that is inside. So we're going to write this as f of g of x. Notice that the g is inside of the function f. And that's how we're going to find this composite function, is by substituting the function g into the function f. So if we do that substitution, we would have 9 over 8 over x minus 8. So we've replaced that x with 8 over x. We're going to simplify this expression now that we've done the substitution. And this is a complex fraction, a fraction inside of a fraction. And there are a few different ways you can go about simplifying this. One way would be to get a common denominator in the bottom here. It would be 9 over 8 over x minus 8x over x. So what I did is I multiplied by x over x to get that common denominator. This gives 9 over 8 minus 8x over x. And now I'm going to rewrite this division. The fraction bar means division. I'm going to rewrite that division as multiplying by the reciprocal. So we're going to get 9 times x over 8 minus 8x. And we'll multiply straight across, multiplying fractions. You multiply numerator times numerator and denominator times denominator, and that gives 9x over 8 minus 8x. Now, I just want to show you one other approach that we could take. We have 9 over 8 over x minus 8. Another technique for simplifying this would be to clear fractions. When you clear fractions, that means you want to get rid of these smaller denominators. And to do that, we're going to multiply by x over x. That would give 9x in the numerator, and in the denominator we would distribute this x to both terms. When we distribute to the first term, the x's cancel and we get 8, and when we distribute to the second term we get minus 8x. So we get the same expression with these two different methods of simplifying. So then we want to state the domain of this composite function. Now typically we would find the domain of just our final answer, but in this case, because we have these individual functions to consider, we have a little bit more work to do. So let's start by finding the domain of these individual functions, and then we'll talk about what the domain of this composite function is. So f of x is 9 over x minus 8. This is a rational function because we have a variable in the denominator. And for rational functions, we want to exclude any values of x that will cause the denominator to be 0, because division by 0 is undefined. So let's set that denominator equal to 0 to find our restricted value. So we set the denominator, x minus 8, equal to 0. We're going to solve by adding 8 to both sides, and we get our restricted value to be 8. The domain is all real numbers except for 8, so we can write that in interval notation. Or if we want to write it in set builder notation, we can say x such that x is not 8. So we're excluding 8 from the domain, but including all other real numbers. Okay, we were going to do the same thing with the function g of x. G of x is x over 8, which is a rational function. We'll set that denominator equal to 0 to find the restricted values, and this time 0 is our restricted value. So we can write that in interval notation. It's negative infinity to 0, union with 0 to infinity, or in set builder notation, x such that x is not equal to 0. That gives the domain of these individual functions. Let's talk about the domain of our composite function, f composed with g of x. Now, to consider our composite function, we have to first think about substituting into g of x. That is the inside function, and so we're going to start excluding 0. So x cannot equal 0. And then we can look to what we got in our final expression here to get any other exclusions. We're going to take 8 minus 8x, set that equal to 0, and solve. We subtract 8. That gives negative 8x minus equals negative 8. Divide by negative 8, and we get x equals 1. So we also need to exclude 1 from our domain. So in our interval notation, we want to exclude 0, and we also want to exclude 1, but we're going to include all other numbers on the real number line. So that gives us a domain of negative infinity to 0, union with 0 to 1, union with 1 to infinity, or in set builder notation, x such that x is not equal to 0 and x is not equal to 1. Okay, let's continue by finding our other composite functions. This time we're going to find g composed with f. And once again, this notation means this notation of composing or operation of composing is substituting one function inside the other. The one before our symbol is the outside. The one after our symbol is the inside. We're going to have g of f of x. So we're going to take our function f of x and substitute it into the function g. This will give 8 over 9 over x minus 8. I'll treat this division, this fraction bar, as division, and we'll multiply by the reciprocal to simplify. That gives 8 times x minus 8 over 9, which is 8x minus 64 over 9. Now, thinking about domain, we're going to start by excluding any values of the inside function. So we found earlier that 8 is a restricted value for f. And then we're going to look at our final answer to see if we get any more restricted values. Since I don't have a variable in the denominator, I'm not going to get another restricted value. So the only restricted value is 8. So the domain is negative infinity to 8, union with 8 to infinity, or in set builder notation, x such that x is not equal to 8. Okay, let's try f composed with f. F composed with f is f of x. So we have f on the outside and f on the inside. So we're taking 9 over x minus 8, and we're substituting that in for x. That gives 9 over x minus 8 minus 8. And we can simplify this by clearing fractions. We'll multiply by x minus 8 over x minus 8. So I multiplied by this little denominator here. That will give 9 times x minus 8 over, we'll distribute in the denominator. When I distribute to the first term, the x minus 8's cancel, and when I distribute to the second term, I get minus 8 times x minus 8. Now I'll simplify. I've got 9x minus 72 and 9 minus negative 8x plus 64. That's 9x minus 72 over negative 8x plus 73. But now we want to find the domain. We're going to start with any restrictions from our inside function, and we can see that 8 needs to be excluded, and then we get any restrictions from our final function. So let's set that negative 8x plus 73 equal to 0. Subtract negative 73, that gives 8x equals negative 73. Divide by negative 8, we get x equals 73 over 8. So 73 over 8 is equal to 9.125. I wanted to figure that out because I wanted to know if 73 over 8 was less than or greater than 8. And I need that for my interval notation. So my domain is negative infinity to 8, union with 8 to 73 over 8, union with 73 over 8 to infinity, or in set builder notation, x such that x is not 8 and x is not 73 over 8. Okay, we've got one more to go. Let's find g composed with g. So g composed with g of x is g of x. G is our outside, g is our inside. So we're taking g of x and we're substituting it in for x. That will give 8 over x. This is 8 times x over 8, which is x. We want to take a look at any restrictions from our inside, and restrictions from our inside are 0. and look to see if you have any restrictions with your final expression, and there are none. And so we just have that one restriction. The domain here is negative infinity to 0, union with 0 to infinity, or in set builder notation, x such that x is not equal to 0. Thank you for checking out my videos. Have a great day.